Welcome to another MIDRC monthly seminar. We keep in mind that these are held monthly, and if you happen to miss one, they are on the MIDRC.org website. They are all recorded. We are very happy for today's topic on what's new in the MIDRC Data Explorer for cohort building. Our speaker is Dr. Chris Meyer. Chris is a data scientist with a background in evolutionary genetics. He currently manages the Gen 3 User Services team at the Center for Translational Data Science at the University of Chicago. And he has been very instrumental in MIDRC's evolution. Gen 3 is an open source software platform for building data commons and analyzing scientific data that hosts MIDRC's Data Commons, which Chris will demonstrate shortly. Chris, welcome to the seminar series, and we look forward to your talk.
Thank you, Mary Ellen. Let me start my video here and share my screen. Okay, so I'll just be going through some slides today, and then we'll probably also intersperse these slides with a live demo of the MIDRC data portal. So again, like Mary Ellen mentioned, my talk is what's new in the MIDRC data portal, specifically focused on cohort building. And just as a brief outline to my talk, there's three main portions. The first, I'll just go quickly over some recent updates to the MIDRC data portal. Again, that I have the URL is there, data.midrc.org. This is the data commons of the MIDRC consortium. And then second, we'll do a live demo and talk about how to build a cohort and access data file objects and structured data in the Data Explorer user interface. And then finally, I'll show you some example analyses that the MIDRC team has put up in the data portal that show you how to do cohort building using MIDRC APIs programmatically. So we'll go over some Jupyter notebooks. I'll show you where they are, where they're located. I'll talk about how to craft and build and send queries using the API. And then show you where you can get these notebook examples and potentially share your own examples with the MIDRC community. So without further ado, we'll just get right into some of the recent updates to the MIDRC data portal. Some of this stuff, if you are not new to MIDRC, will be a bit of a recap, but I think this will get some of the most important, newest additions to the data portal out there for folks to consider. The first of which, and we'll do a live demo of this, but just to show you really quick some 4 bullet points. We have an integrated DICOM viewer. The DICOM viewer is available in the Imaging Studies tab of the Data Explorer. To view an imaging study and all the series within that study, you can click on the Browse in DICOM Viewer button, which is in the table of data. And you can see there in the slide towards the bottom, that button, which will open up a new tab in your browser where you can use the OHIF, which is a DICOM viewer software. It's open source that we've integrated into the Gen 3. To just do a preview of images. It has some tools that we can look at here in a bit. Some other relatively new additions. I think the last time I spoke to this group, we had just started this work of LOINC harmonization of imaging studies. So there is a committee on data quality and harmonization called DQH, and that committee has a panel of experts that have gone through the very large number of study descriptions that come in to MIDRC in the raw data, which are unharmonized and many of which have overlapping meaning. They've taken those very diverse study descriptions and harmonized them using the LOINC playbook. The mapping table of raw study description to harmonized study description is in GitHub, along with some of the code that we use for processing those study descriptions and doing the harmonization. And just to give you an idea of where we're at as of today, we have successfully mapped 98%, a little bit over 98% of all ingested imaging studies, which is about 123, close to 124,000 imaging studies out of 126,000 roughly. So I think that's a really big accomplishment, and I encourage folks to check out those LOINC properties, which may be useful for your cohort building. And we'll also look at that in the live demo here in a minute. A third thing that I'm really proud of that we've done is the Gen 3 team. We run the help desk, and we get user requests and use cases sent to us fairly often. And I want to encourage anyone who's listening to this webinar to note that support email and use it if you have any kind of feedback, not just a question about how to use the data portal, but if you have a suggestion on what would be useful for your cohort building activities, please do drop us a line and let us know your use cases. So this is one of those use cases. We were asked, or we were told that it would be very helpful if we could put imaging studies on a timeline with respect to positive and negative COVID test results. And so we have done some calculations and ingested that data into the MIDRC portal. So we now have on the imaging studies tab some filter options, which allows you to select a range of days to create a window in time around an imaging study from a positive or a negative COVID test result. And then you can see over here on the right in this red box, those two properties, which are in the data model now and available for queries. And so each imaging study is a row in this table, and the values are the distance from that imaging study and time to all of the COVID test results for that patient. So it is a list of values. And then finally, we've added a measurements tab to the Data Explorer, where you can go to Explore and download all of the COVID-19 test data for all the patients in MIDRC. You can see there in the screenshot, we've got about 128,000 COVID tests, some RT-PCR, some rapid test data, and you can download those data or use that information to select a cohort of patients. For example, if you only wanted the PCR positive results, you could make that selection to build a cohort. Okay, so without further ado, we'll just get right into how to build a cohort in the Data Explorer. We'll look at some of the components of the Data Explorer, and then we'll do the live demo. So when you go to data.midrc.org, you can get to the exploration page using that first navigation button there in the top navigation bar called Exploration, and I've highlighted it here. That will take you to the main Explorer page, where at the very top of the page, you'll see currently 4 tabs, although I should mention now everything on this page is entirely customizable. So while there's 4 tabs now, there could be more in the future. And that is another example of something we welcome your feedback on. If there's particular filters or tables of data that you'd like to use faceted search on, we can certainly look into creating more. But currently we have tabs for cases, measurements, imaging studies, and imaging series. Each of these tabs, when you click a tab, will load filters on the left and some charts here, as well as the actual table of data there at the bottom. And it is a flattened table of data. So I say flattened because it is based off of the MIDRC data model, which is a relational graph-like model. So these tables, basically, if you're looking at a table of imaging studies, we can pull in all the related properties from nodes that are linked to the imaging study node, like data like case demographics or clinical data, or from levels below, like the imaging series, DICOM parameters, and we can put it all in a single table. And this is based on Elasticsearch for quick filtering. Yeah, so the filters mainly include patient demographics, clinical data, and the DICOM tags from the headers of the images. And soon we're currently working on adding annotations to the data model. So there will probably be a new tab soon, or at least new filters on these existing tabs where you can use annotation data to build cohorts as well. So besides the filters, which filter the data table, to build your cohort, sort of the meat and potatoes are these two buttons up here. The one on the left that says download imaging studies table. You can export that table of structured data. Again, when you click on a filter, it will do fast filtering of that table. So it will export, that button will export the table of filtered data. You're also welcome to not do any filtering at all and just download the table straight away to get all of the data if you'd like. And then the button on the right, which says download file manifest for imaging studies. What that button does is for every selected imaging study on the page in the table of data, it will generate a file object download manifest for that selected cohort, which means, let's say there's three, you've selected a CT imaging study and there's 3 series in that study. If you created a manifest for that one study, it would contain 3 files, and then you could use our MIDRC download tools to download those files and access those file objects, which are in cloud storage. Just for your understanding of how the Explorer works and some of what's going on in the background when you click on all the buttons and do filtering of the table of data, the Explorer application is based on queries. So when you make a selection, like let's say you filter all the imaging studies for the CT modality, that's actually sending a query to the MIDRC APIs, and it's getting, the API is sending a response, and then that response is loaded into the user interface that displays the table of data and populates the buttons that lets you, download the table of data and get the files. So all of this is based on the data model. So I do want to point out that even though in the Explorer presents this graphical user interface that makes it easy to do cohort selection, that on the back end there is a relational model, and that relational model is what our data is ingested into. It consists of interconnected nodes, and each node can be thought of as a table of data. So the case node here at the top in the screenshot is a table of patients, and those patients are related to, for example, their clinical data. You can see under there, like conditions, medications, observations, procedures, as well as imaging files like CR series files, etc. It's also worth noting that if you are so inclined that you would like to learn how to write your own queries, we facilitate that by offering a query builder, and I'll show that here in a minute as well. Then it helps you build queries. So this is just the last slide here before I demonstrate some of this. So the graph, it's called the graphical, it's based on GraphQL query builder. And you can get to this by clicking the query button in the navigation bar, or you can navigate to data.midric.org/query. And the cool thing about the query builder is that it's got built-in schema documentation. So you can click docs and view each table of data, view what properties, what data elements are available to query and what types they take. So you can sort of see there on the right. I don't know if it's large enough to see on your screen, but for example, you can query imaging data files, body part examined, and that's a string. Or you could query age at imaging, and that's a number or a float. So that's very handy in understanding what's available to query. And then, of course, also very neat is GraphQL can be a little tough to learn if you're new to the syntax. And this query builder has autocomplete and will make suggestions and highlight errors in your syntax. So that's also very useful. And finally, there's a button to switch between API endpoints between our Postgres database, which is our source of truth database, and the Elasticsearch database, which are those flattened tables of data that facilitate the very quick filtering that you find on the Explorer application. And that's all I'll say about that for now. So now just getting over to the live demo portion of the Exploration app. I'm just going to show how to select a cohort of cases based on demographic data and export that table of structured data, as well as get an image file download manifest for that selected cohort. I'll show you where to find the COVID-19 test information and download that data. We'll take a look at how to preview imaging studies in the integrated DICOM viewer, and then how to subset or filter the imaging studies based on some of those new properties we've added to the dictionary and the exploration tool that I mentioned at the beginning of the talk. So the proximity and time to COVID-19 test results, and of course the harmonized LOINC attributes. And then I'll just do a quick demo of showing you how you can take that file download manifest and use our tools to access files. So now I will click over to my browser. And okay. So this is the landing page of the MIDRC Data Commons. Since we're talking about what's new in MIDRC, I should mention that besides some of the new filters and tools I'm about to show you, since I last spoke to this group, one big thing that's new is quite a bit more data. I'm really proud of the work we've done this past year. We've really ingested a lot of data. We've created pipelines and processes to make the data ingestion process go more smoothly. So we were really hitting our stride, and we expect even more data in the coming year. So next time you check, these numbers will almost certainly have gone up. We do a monthly data release. I think the last time I spoke to this group, we were closer to 25,000 cases and 70,000 imaging studies. So we've nearly doubled those numbers. And yeah, that's something to be really proud about. It's a great data resource, and I really hope that people listening will use it. So just to show you how to dive in here and start using MIDRC, I had mentioned that the exploration page is based on the dictionary. So there's the dictionary button here. So if there's anything in the exploration page, like for example, when we navigate to the Data Explorer, you can see, well, some of these case demographic properties like sex, race, ethnicity, age. These are relatively straightforward. I don't think anyone is going to be too confused about what those mean. But we do have a data dictionary. And if you ever do see a property on that page that you're unsure of, you can go to the dictionary and you can view it as a graph or as a table. And then you can view the properties in that node and their definitions. So if you need some clarification, like for example, age, we have this note that we don't store ages greater than 89 years. So if someone's like 92 years old, then they get a yes for age at index is greater than 89. So I would encourage you, if you're coming to MIDRC, thinking about doing research, you're building a cohort using some filters that before you write your research paper, just make sure you do a review of the dictionary, make sure you're not misinterpreting anything. Also very useful to come here just to see what's available in MIDRC, because it may not be obvious from just browsing through the data, what the rich data set that we have. So back to the Explorer, just wanted to give a plug for the data dictionary again. Okay, so the tabs here at the top, like I mentioned, represent tables of data. So right now we're looking at the case table. And you can see, like right off the bat here in the middle, there's some charts. It shows you how many cases there are, and then there's filters here on the right. If I keep scrolling towards the bottom, you get to the actual table of data. So this is what's available when you're browsing cases. You can sort these. You can sort these columns if you'd like as well. But the real meat and potatoes here are the filters. This is called faceted search. It's an inclusive selection. So I can, for example, if I'm interested in only females in my research, I can make that selection, and you can see it's extremely quick filtering of the data table, which is why we bring this data into Elasticsearch. And then you can just keep making selections to narrow your cohort to whatever cohort you'd like. Let's say I'm interested in Asians and Native American Indians, so you can make multiple selections on these, make whatever selections you'd like. And this is, like I said, inclusive. So as I check more boxes, it's adding cases. If I remove boxes, it's lowering the number of cases. Once I'm happy with my, let's say I'd like ages 60 to 89, I can make a range selection there for a numeric property. And I'd like COVID-19 positive cases. And let's say I only want the ones in this particular project. Okay, I've narrowed it down pretty far to 36 out of, it was 55,000 cases. Just for example's sake, so we can download this table of data that we see here, this filtered table of 36 cases, using this download button. We can, there's some options. You can get it as a JSON, a TSV, or a CSV. And that will literally just be, oh, it's prompting me to log in. So to view the data in MIDRC, you can be anonymous, but if you'd like to download the data, you do have to be logged in. So let's just really quickly make another selection. And yeah, so you can check one of these boxes that you'd like and download the data. And you can see that was pretty quick there. And there it is. There's our table of case data that we filtered. Okay, so to get the files for those cases, so that's just the structured data. Let's say we now want all of the images for the selection we've made here for these 1,300 cases in this case. We can download this file manifest. What it does is generates a manifest JSON. And I'm just going to save it here to my laptop. If you're curious what this looks like, the contents look like this. So there's just, it's a JSON, so it's a list of dictionaries, and one of the fields is object ID. Object ID is what you're going to use to access the files. So then I can come to the terminal, my terminal window, and I can run a Gen3 client download command. and you can see it'll start downloading the files. So I'm not going to actually go through with this because I don't want to rack up any egress charges that are unnecessary. So I'm going to kill that process, but just to show you that, yeah, you can use that manifest file that we've generated in the Explorer for bulk download of the data that we're interested in. Okay, I had mentioned that there's a measurements table. These are the COVID-19 test data. That's literally what it is right now. I'm currently working on getting this test information merged into the cases table so that we can filter, get the file object download manifest based off of these. Currently, you can just download this data as a TSV or CSV or JSON, and then you can use. Let's say you're interested in PCR tests that are positive. You can make those selections, and you can see all the cases that have had positive PCR test results, and then use the button to download them. So that's the measurements table. Imaging studies. Now this is where things get a lot more interesting. So you can see there's 126,000 imaging studies. And right off the bat here, this is where this is the first tab here where we see multiple filter tabs. So you can filter imaging studies based on case demographics. You can filter them based on file properties like the modality or type of data file. Here are the LOINC properties that I've pulled out into a separate tab. So you can see all of the harmonized LOINC study descriptions there. The harmonized LOINC modality. Notably here, I think the main thing is CR and DX are merged into XR. The system, which is also a body part examined, whether or not the image has contrast, and the LOINC code that it was mapped to. And you can see there's quite a few of them, and not very many that have no data here currently. And then finally, what I wanted to point out were those temporal properties, so that you can select imaging studies based on their proximity to a COVID test. So for example, I think for it to be meaningful, you've got to make a relatively small window. So we'll just say set -7 to 7. So this is just building a 1 week window, plus or minus in days from a positive COVID test. So the table is filtered down to 20,000 imaging studies, and each of these imaging studies should have a COVID test, a positive COVID test result that took place within a week of that imaging study date. And then again, you can use these buttons to either download the table of data, or you can click this button. Again, this will generate a file download manifest for these 20,000 studies. The little number there in parentheses, that 38.17K, that is the number of files in the download manifest. So for 20,000 imaging studies, you've got about 38,000 files. And then finally, imaging series. This is more or less the same as imaging studies, except down one level in the DICOM hierarchy. So there's multiple imaging series often in an imaging study. So you can slice and dice imaging series on their own outside the context of a study. And we offer properties that have been extracted from the DICOM headers of these images. And this is, again, where we would welcome your feedback. If you, for example, know of a particular DICOM header, like exposure modulation type or contrast bolus agent that would aid you in building a cohort, let us know, and we can add these as filters to the Data Explorer. And of course, there's you can download the table and a file manifest. Jumping back to the imaging studies tab really quick, let's select CT here. And we'll scroll down to the table, and you can see this first column here is browse in DICOM viewer. So if I want to view on the fly one of these imaging studies, I can click that button and it starts to load the imaging series in that study into the left-hand panel here. You can see there's some scout images. First off, those aren't very interesting. But then we have I think a coronal CT here with 600 slices, and we can use our mouse to move through that stack of images so we can get a three-dimensional idea of the image of the CT here. So that's, and this isn't just available for CTs, but I think the CT is more interesting for demonstrations. There are some tools, built-in tools in the OHIF browser. But yeah, this is more or less for previewing images. Okay, that was a very quick tour of the Exploration app. I showed you the dictionary, which I would encourage you to take a look at. Here is the query page. Again, this is not super user-friendly, but it does come with documentation here. So if you click this docs button, you can find, so if I want to know what are the different things I can query on the imaging data file node, I can click there and it gives me a list and it helps me build a query. So you can see here I'm asking for imaging data files and I want the object ID and the study description. And I'm saying I want it to be in this particular project. And I can add any filters that I would have used in the Data Explorer here as well to get the response directly from the API instead of using that tool. Okay, I think I'm running shorter on time than I'd hoped here, as usual. But just to, I won't go through the notebook because we wanted to focus on the data exploration app this time. But just to give a shout out to the MIDRC APIs, which power that Explorer tool we just looked at. We do have an example notebooks page now. And just to slide back over to MIDRC really quick, I'll show you that page. These example notebooks, these are Jupyter notebooks, which are typically contain either Python or R code. And they just show you, this is a growing collection. And I do encourage you to create your own notebooks, maybe take a look at one of ours and then base your own analysis off of it. And if you'd like to share it, we'd love to have you upload it to the GitHub repository. So there's a link to that GitHub repository here. I think if you click on one of these, it'll just show you a static HTML version of the notebook, just so you can get an idea. Of course, you can copy the code if you'd like, but if you want the executable, if you click on this button here, it'll take you to the GitHub repository where you can download the IPython notebook files. So yeah, I encourage you to take a look there. And yeah, I'd intended to show you a few examples of some queries, but I want to leave time for some Q&A, so we won't dig into that. But I do welcome you to take a look at those notebooks if you're so inclined, and try some of those queries out for yourself. Just to say why we're doing that, as opposed to just building the graphical user interface. So often, I mean, we really want researchers to use MIDRC, and researchers often have custom needs for their research. So if you have a particular need and with respect to cohort building that's particularly complex or is custom in some way that just doesn't meet the typical use case, that will require sending API requests using our queries of the MIDRC APIs. Those notebooks will help you out a whole lot. Just as an example, we recently had someone ask, hey, I don't want all of the CR images for all the patients that I've selected. I just want one CR image per patient. Whereas when I click that file download manifest button, it dumps all of the files into that file manifest. So I can't figure out sort of how to get that just one file per patient. And I don't want to download a bunch of stuff and then have to delete half of it. So we wrote some custom GraphQL queries that limited the data return to just one scan per patient. And that's in a notebook. We'll be adding that one to the examples page here pretty soon. And yeah, those notebooks show you how to authenticate with the MIDRC APIs using your personal credentials, how to send queries to the MIDRC API to build a cohort, just like we did in the Explorer, but we're doing it programmatically using queries. How to get the file identifiers for that cohort of imaging studies or patients that you've built, and then how to access the files, how to actually download the files using that manifest. So that's it. I think I went a little bit over, but we still have some time here for a Q&A. So thank you so much for listening. I really hope researchers out there will feel like they can go to MIDRC now and start doing some research. Thank you.
Thank you, Chris. That was as always, enlightening. Thank you very much. For questions, please put your questions in the Q&A, and then of course I will have some. There was one in the Q&A. If you click on it, Chris, does a negative value for the data element days to negative positive tests indicate imaging was before or after the test? Looking in the data dictionary, we have a answer. I think, are you able to see that? If you
I lost my Zoom. Where did it go?
Yeah, we see you.
There we go.
Okay, so if you do the Q&A at the bottom, basically this is when you nicely showed how you picked plus or minus 7 days to do your query for the linking the COVID test with the imaging exam. And this was a question, does the negative value, so if you were able to press on the Q&A?
Yeah, I think I've got the question here. Yeah, so so the way we think about it is it's in relation to a study. So if we think of the imaging study as day 0 in this case, a positive value would mean moving forward in time. So if the days from the study to the test is 3, that means the test took place 3 days after the study. If it was -3, that means the test was 3 days before the study.
Great, thank you. And that agrees with what I typed in. So that's wonderful. And to get to these various answers, one would just go to the data model and either in the graphical or in the table format and find it. Other questions? I actually have one. I really enjoyed how you went through and used the Data Explorer to create cohorts. So, and with that, you clicked on different characteristics of the patient or the data or the type of imaging exam. And you were able to build a cohort. And that way, when you downloaded the images, you only downloaded what you needed. You then went on and talked about the query graphs, where one could even fine tune it better for one to download. And as I was thinking about that, perhaps you can comment that for people who go in and download all 120,000 imaging studies, which is many, many terabytes, they would then have to do the cohort building and the slicing and dicing on their computer. And I think that's really important. And, we're not just at Data Commons. If you can comment on, I know you talked about it in your talk, but I think stressing that is really important.
Yeah, I meant to stress that, and I forgot to get into it, as always happens when I start looking at my slides. But yeah, I wanted to thanks for queuing that up, Mary Ellen. I do want to say that what's the difference between MIDRC and a Dropbox or just a data lake. It's more than just a data repository or a data warehouse because of the data model. Largely, the data model is our way that we harmonize the data and we make it searchable. So, that's right. We do strive to add not every data element that's in the raw data to the data model and expose that to queries, but for capturing the most common use cases. And that's why I've asked folks to email the support desk. Oh, and I forgot to show that email address. Your use cases, we can help we can help add new things to the data model. Yeah, so this button up here, email support, and the top right is how you would send feedback, and that email there is midric-support@datacommons.io. But yeah, we can use queries to refine our search, and yeah, it's just as an example, here's that Jupyter notebook. I will put this in the example analyses soon, but it's very well documented. It explains like what each of the arguments is, what's being returned, and I show you the query and how to send that query, and then how to do a little bit of post-processing just to loop through the results, pull out the things you're interested in, build a manifest, and download the files. So yeah, you can use queries to really refine the data set that you're downloading instead of just downloading everything and then wading through it later.
Yeah, thank you. Right, and to folks, if you download everything, it's going to take time, and then you have the job of looking for what you want. Use the MIDRC tools, as Chris nicely went through, to help you find the cases you really want. So Chris, there's another question. It says, does MIDRC support collecting DOI for citing the data cohort used? And
yeah, so Marilyn, I think that you may know when that's coming better than I do, but yes, we are currently in discussions about implementing DOIs for data sets in Gen 3 in general, but in MIDRC, that is coming soon, I believe, for reproducibility purposes and data citations for papers and things like that. So yeah, very soon we will have DOI support. I can't personally speak too much about that at this time because I think some of the details are still being worked out in the timeline as well.
yes, and so that's under very active development. So check back with MIDRC very soon. Other questions. I really enjoyed seeing the query builder, which I know you just mentioned that again, but it really gives the MIDRC user multiple options to learn, to use MIDRC, using the tabs on the left in the Explorer. If you want to get more sophisticated, using the query builder. So you have access to a lot of data in there. Does the query builder allow you access to data that probably is in the data model, but not, well, does the query builder give you access to data elements that are not, or data characteristics, I should say, that are not necessarily in the data model, but would be in the files?
No. So I thought you were going somewhere else with your question. So it doesn't give you access to file contents.
Okay.
The queries are entirely based off of the data model and what data that we have stored in our Postgres database. That we call it structured data, also metadata. So the data that is ingested that describes the files and the files are related to. So we use that structured metadata to empower queries to get at the files. Gen 3 and MIDRC, when there's a file in object storage and in cloud storage, there's no way to sort of peek into that file and get anything out of the file itself. You would have to download the file. But that's exactly why we encourage learning how to query, I mean, either through the exploration tool or building your own custom queries, because otherwise, to get at that data, you're going to have to download everything and open the files and read them, as opposed to, we've done a lot of work to try and take the relevant things out of, the relevant data attributes out of all the files and expose them to the API for queries. So if there's something in a file, again, that you feel like as a researcher is important to build a cohort or subset the data on, and you don't see that in the exploration application, please email us, let us know what your use case is, and we'll get back to you and hopefully be able to implement that.
Okay, no, great answer. Thank you, Chris. And thank you again for giving the talk and the demos. This concludes, we're at the 45-minute mark. And we look forward to seeing everyone at our MIDRC seminar in May. And I think this was a great demonstration of how MIDRC and Gen 3 really aim to help the end user, the investigator who needs this AI ML ready data. So use that help button. It's been a great resource. So thank you all. Bye-bye.